Shanbhag the paper guy. Shanbhag the paper guy. Shanbhag the paper guy. Science rules. Shanbhag the paper guy.
Everything on our planet is experiencing some kind of force. You, me, or even some of these planes.
Whoa.
Now, what is a force? Well, a force is a push or a pull that requires the presence of two objects. Now, according to all known laws of aviation, any one of these beauties should be able to fly.
Did you know that?
Did you know that if a force doesn't act on this plane, which is currently at rest, it will remain at rest?
Really?
This is because of Newton's first law. Any object at rest will remain at rest unless acted upon by an external, unbalanced force, such as the applied force from a hand. Now, Newton's laws, the first law, also states that an object in motion will stay in motion, and the same is true for that plane. Let's try it out with a nifty home experiment.
Now you know.
Here we have a simulated vacuum room without gravity. Victor represents a force, and he changes the paper plane's motion. If Victor hadn't acted on the plane, it would have continued in uniform motion. Why don't you guys try it at home?
Consider the following.
Consider the following. If a paper airplane is heavier than another paper airplane, will they fly the same way?
Oh, I don't know.
Let's test that out. Here, we have two paper airplanes, one of which has a greater mass because of the two pens on the bottom of it. What happens when we push them off at the same time? Let's find out.
So as you can see, despite hitting the planes off with the same force, one plane accelerates much faster than the other.
When you propel two different paper airplanes with the same net force, what we see is that the paper airplane with the lower mass will experience greater acceleration. Now, why is this? Well, according to Newton's second law of motion, the acceleration of an object is directly proportionate to net force in terms of direction as well as magnitude, while being inversely proportionate to the mass of the object. What this equates to is that an object with a smaller mass will experience a greater acceleration, which is what we saw in the demonstration previously shown. This can be seen using the equation net force equals mass times acceleration, which we can furthermore rearrange into acceleration equals net force divided by mass. Okay, for example, let's say I hit the two planes with a net force of 12 newtons, and let's pretend that the lighter plane has a mass of 3 kilograms and the heavier plane has a mass of 4 kilograms. Well, if we plug these numbers into the equation, what we see is that the plane with a mass of 3 kilograms will experience an acceleration at 4 meters per second squared, whereas the plane with 4 kilograms, which is the heavier plane, experiences an acceleration of only 3 meters per second squared, which is lesser than that of the plane with the lighter mass, which in turn reinforces the idea that the lighter plane will accelerate faster.
Thank you for considering the following. Have you ever wondered what happens when a paper airplane, collides with something in midair? Well, check this out. As you can see, not only did the plane meet the wall with a force against the wall, but the wall met the plane with an equal force, which caused the plane to recoil. Now, I'm sure you're wondering why that is. Well, according to Newton's third law of motion, every action in an object is met with a reaction that's equal in magnitude, but opposite in direction. Now, what does that mean? As we've seen from the past experiment, when I hit the wall with my paper airplane, not only did the wall recoil, but the paper airplane recoiled too from the opposite force that was equal in magnitude from the wall, pushing the paper plane back and letting it recoil and drop to the ground. That is Newton's third law. That's pretty neat, kids.
1, 2, 3, science. 1. An object's motion will only change if acted upon by an unbalanced external force. 2. Acceleration is proportional to net force and inversely proportional to mass. 3. Every action force has a reaction force equal in magnitude and opposite in direction. 1, 2, 3, science.